Hi guys, let's take a look at this question where we have a small isolated sphere A that has a mass of 0.2 grams and it's carrying a charge of plus 7 times 10 to the power of negative 9 coulombs, and it is suspended from a horizontal surface by a string of negligible mass. Then we have a second sphere B right there that's carrying a charge of negative 8 times 10 to the power of negative 9 coulombs, and it's on an isolated stand, and it attracts sphere A so that the string forms an angle 20 degrees to the vertical. The horizontal distance between the two centers of the two spheres is 3 centimeters, and they've drawn a nice diagram for us to see all of this. 9.1. State Coulomb's law in words. Please know this by head. Coulomb's law is the magnitude of the electrostatic force exerted by 2 point charges on each other is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. 9.2. Draw a vector diagram of the forces acting on sphere A and indicate at least one angle. So a vector diagram. So what do we have? We have our Fg coming down here, our weight. Then we have our electrostatic force. Remember that force there. Then we have the tension from the string going up. And then remember we have that 20 degrees to the vertical. And that is how the vector diagram should look like. Another way you could draw it is like this. You could draw Fg down. If this makes more sense to you, Fe across. They're usually the same length. This has to be a little bit longer. And then we have the tension pulling up. And then you just draw the 20 degrees right there. Either or would be fine. Last one, 9.3. Calculate the magnitude of the electrostatic force that sphere B exerts on sphere A. So which formula do we use? We will probably use this one, right? So we can say that 9.3, first write down your formula. Why? Because you get a mark for the formula. I sound like a robot. You have your constant of 9 times 10 to the power of 9. We have our one charge, which is negative 8 times 10 to the power of negative 9. And we have our other charge, which is positive 7 times 10 to the power of negative 9. Then the distance between that two charges is 3 centimeters. So we have to change that to meters. So we divide by 100. So 0.03 squared, and we jot that into the calculator, and we get the force to be 5.60 times 10 to the power of negative 4 newtons. And that is the electrostatic force that sphere B exerts on sphere A. And that is it, guys. See ya.